Not because they are easy, but because they are hard.
In 2 years, NASA plans to land humans on the moon. On July 20th, 1969, Neil Armstrong and Buzz Aldrin became the first humans ever to step on the moon. Over the following 3.5 years, 5 more missions successfully landed 10 more astronauts on the lunar surface. Then, things ended. After Apollo 17 in 1972, the program came to a close. And with NASA now pursuing the Space Shuttle program, attention was redirected away from the moon back to low Earth orbit. Things stayed this way for over 30 years. Then, in 2004, the Bush administration announced the Constellation program, an initiative with the goal of returning humans to the moon by 2020.
It is time for America to take the next steps. Today, I announce a new plan to explore space and extend a human presence across our solar system.
However, in 2009, the Obama administration established the Augustine Committee, which discovered that the Constellation program was massively underfunded and that a 2020 moon landing was impossible. With this information, the Obama administration signed the NASA Authorization Act of 2010, which scrapped the Constellation program and called for the immediate development of the Space Launch System, a super heavy lift launch vehicle capable of supporting crewed missions beyond low Earth orbit and eventually to Mars. In addition, the act called for the continued development of Constellation's Orion crew capsule, which would be used for these future missions. For several years, testing and development of the SLS and Orion advanced. Then, on December 11, 2017, the Trump administration signed Space Policy Directive 1, a strategy calling for a US-led coalition of international and private partners to return humans to the moon by 2025 and establish a permanent presence, laying the foundation for future missions to Mars and beyond. On May 14, 2019, NASA Administrator Jim Bridenstine announced that the new program would be called Artemis, after the ancient Greek goddess of the moon and the twin sister to Apollo. A year later, Bridenstine announced the Artemis Accords, a series of agreements with partner nations to establish a governing framework for Artemis, guaranteeing peaceful and civil exploration of the moon. Then, on October 13, 2020, representatives from Australia, Canada, Italy, Japan, Luxembourg, the UAE, the UK, and the US signed the Accords. Since then, 15 more nations have signed the agreement, making Artemis a truly international endeavor. To return humans to the moon, the Artemis program has 4 main components: the Space Launch System, the Orion spacecraft, the Human Landing System, and Gateway. The Space Launch System, or SLS, is the most powerful rocket NASA has ever built. Its design, which is based off the Space Shuttle system, consists of a core stage built by Boeing, measuring 65 meters in length and 8.4 meters in diameter. It consists of a 2 million liter liquid hydrogen tank and 742,000 liter liquid oxygen tank, along with 4 Aerojet Rocketdyne RS-25 engines with a total sea level thrust of 7.4 meganewtons. To power the initial ascent, SLS has 2 5-stage solid rocket boosters attached to the core stage, measuring 54 meters in length and 3.7 meters in diameter. Built by Northrop Grumman, these boosters will burn for only 127 seconds, but will generate a combined thrust of 32 meganewtons, over 80% of SLS's total thrust at launch. Lastly, secured to the top of the core stage is the interim cryogenic propulsion stage, built by the United Launch Alliance. This second stage measures 13.7 meters in length and 5 meters in diameter. It contains liquid hydrogen and oxygen tanks, along with a 110 kilonewton Aerojet Rocketdyne RL-10 engine. Once in orbit, this engine will perform the translunar injection burn, boosting Orion from Earth towards the moon. This original SLS configuration, named Block 1, will be used for Artemis missions 1 through 3. For following missions, though, Artemis will use a larger variant called SLS Block 1B, which will replace the interim cryogenic propulsion stage with the larger Exploration Upper Stage. Built by Boeing, the Exploration Upper Stage will have liquid oxygen and hydrogen tanks, along with 4 Aerojet Rocketdyne RL-10C3 engines, with a total thrust of 433 kilonewtons. This additional power will enable SLS to launch up to 42 metric tons into translunar injection, compared to 27 tons for the Block 1 variant. Eventually, Block 1B will then be upgraded to Block 2, which will use higher performance solid rocket boosters, enabling 46 tons of payload to be placed into translunar injection. The Orion spacecraft will carry astronauts to and from lunar orbit and consists of 2 sections. The first section is a 5-meter diameter, 3.3-meter tall habitable crew module, with space for 4 astronauts. Designed by Lockheed Martin, it has the same basic configuration as the Apollo Command and Service module, but with an increased diameter, an updated thermal protection system, and other modern technologies. Attached to the crew module is Orion's second section, the European Service Module. Designed by Airbus, it has a diameter and length of 4 meters and is equipped with 4 7-meter-long solar wings. It will provide power, propulsion, air, water, and thermal control for Orion, allowing it to support 4 astronauts for up to 21 days undocked and 6 months docked. Lastly, Orion is equipped with a launch abort system that will quickly eject the crew module away from the rest of the launch vehicle in the case of an emergency. While Orion will carry astronauts to lunar orbit, in order to land them on the surface, a Human Landing System, or HLS, is required. This is the equivalent to the lunar module from the Apollo missions. Rather than leading HLS development itself, in 2019, NASA asked industry leaders to develop their own HLS solutions and compete for a NASA contract. In November 2019, 5 companies submitted proposals. And in April 2020, 3 teams advanced to design contracts. The Blue Origin-led national team, SpaceX, and Dynetics. Then, on April 16, 2021, in a controversial decision, NASA selected only one design to move forward: SpaceX's Starship HLS system. Starship HLS, which is a variant of SpaceX's Starship, will have a length of 50 meters and diameter of 9 meters. It will be launched into orbit on a SpaceX Super Heavy booster. It will then be refueled by multiple Starship tankers before boosting itself into a lunar orbit. For Artemis 3, the Starship will rendezvous directly with Orion, whereas for Artemis 4, it will rendezvous with Gateway in preparation for the crew's arrival. After receiving the crews, Starship HLS will then descend to the lunar surface and stay for several days, before launching back into orbit. Finally, after returning the crew to Orion, it will dispose of itself by boosting into a heliocentric orbit. To ensure this process runs smoothly, Starship HLS will perform an uncrewed demo mission sometime in 2024. If successful, it will then be used for Artemis 3 and 4. However, only for these missions. For Artemis 5 and onwards, NASA has established the Lunar Exploration Transportation Services Program, or LETS, with the goal of developing a long-term sustainable lander solution. Blue Origin and Dynetics are now focusing their attention on the second contract with their Blue Moon and Dynetics HLS systems. SpaceX, on the other hand, is hopeful that Starship HLS will prove itself during Artemis 3 and 4, winning itself a contract extension. In order to establish a permanent human presence on the Moon, the Artemis program needs a staging ground to initiate and support surface operations. As a result, in 2017, NASA announced plans for Gateway, the world's first space station beyond low Earth orbit. The station, which will be placed in a near-rectilinear halo orbit around the Moon, will be able to adjust its orbit, enabling it to land and support astronauts all across the lunar surface. In order to achieve this, Gateway will be built in several stages. The initial configuration will consist of 2 elements: the Habitation and Logistics Outpost, or HALO, and the Power and Propulsion element. HALO, which is being built by Northrop Grumman, has a diameter of 3 meters and length of 6 meters. It will provide living and working spaces, in addition to ports for connecting with other elements. Meanwhile, the Power and Propulsion element, which is being built by Maxar Technologies, will generate 60 kilowatts of solar electron ion propulsion while serving as the communication center of Gateway. These elements are planned to launch in November 2024 using a SpaceX Falcon 9 Heavy launcher. They will be mounted with numerous scientific instruments, including NASA's Hermes, which will study space weather fluctuations caused by the Sun, and ESA's Ursa, which will study deep space radiation. In preparation for Gateway's first crewed entrance as part of Artemis 4, the station will be expanded with the addition of the IHAB. IHAB, which is being built by ESA and JAXA, has a diameter of 3.4 meters and length of 5.9 meters. It will provide additional living and working spaces, in addition to ports for docking with Orion and other elements. Sometime between Artemis 4 and 5, a SpaceX Dragon XL logistics module will then deliver Canadarm3, a Canadian-built 8.5-meter-long robotic arm system. It will inspect and repair Gateway, capture visiting vehicles, relocate modules, and help astronauts during spacewalks. Then, when Orion arrives with the Artemis 5 crew, it will deliver the ESA-built Esprit module. With a length of 6.4 meters and diameter of 4.6 meters, Esprit will provide hydrazine and xenon refueling for the power and propulsion element, in addition to a habitation area, more communications equipment, and storage. Finally, when Orion arrives with the Artemis 6 crew, it will deliver the last module, an airlock that will allow the crew to perform spacewalks. In order to get all these modules into lunar orbit, a whole lot of math and science knowledge is needed. Fortunately, with today's sponsor, Brilliant.org, you can learn these topics right from home. Brilliant is an online community with thousands of fascinating lessons on math, physics, computer science, and much more. Their courses are highly interactive, providing a next-level learning experience. Right now, I'm enjoying Brilliant's course on gravitational physics. As an aerospace engineering student, this course is helping cement my astrodynamics knowledge, boosting my confidence and giving me an edge. The best way to invest is in yourself, and Brilliant makes it fun and simple. To sharpen your mind and try everything Brilliant has to offer free for a full 30 days, visit brilliant.org/futurology channel or click on the link in the description. And for the first 200 people, you will also get 20% off your annual subscription. Thank you, Brilliant, and now back to the video. On November 16, 2022, at 1:47 p.m. Eastern Standard Time, on Launch Complex 39B at the Kennedy Space Center in Cape Canaveral, Florida, Artemis 1 launched. The launch would provide the first uncrewed test of the SLS and Orion. After 2 minutes and 12 seconds, the SLS's solid rocket boosters detached, and 5 minutes 51 seconds after that, the main engine cut off and the core stage separated. 81 minutes later, the second stage began the translunar injection burn, and 28 minutes after that, it separated from Orion, along with 10 CubeSat satellites. 5 days later, Orion intercepted the moon and performed a flyby, before inserting itself into a distant retrograde lunar orbit. After 6 days in this orbit, Orion departed it and performed another flyby of the moon before propelling itself back to Earth. After re-entering the atmosphere, Orion deployed its parachutes, and on December 11, 2022, at 12:50 p.m. Eastern Standard Time,
Splashdown. From Tranquility Base to Taurus Littrow to the tranquil waters of the Pacific, the latest chapter of NASA's journey to the moon comes to a close. Orion, back on Earth.
the splashdown, which occurred 50 years to the day from the last Apollo 17 lunar landing, marked the successful start of the Artemis program and NASA's return to the moon. Artemis's second mission is planned to launch in late 2024 or early 2025. It will be the first crewed test of the SLS and Orion. An SLS Block 1 will launch Orion along with 4 astronauts into an Earth orbit. Orion will then be boosted into a free return trajectory around the moon, where it will remain for 10 days before returning to Earth for re-entry and splashdown. The mission, which will take astronauts the farthest humanity has ever gone out in the solar system, will set the stage for Artemis's first lunar landing. The third Artemis mission is planned to launch in 2025, but will likely be pushed back to 2026. It will be the first crewed lunar landing since Apollo 17, and will land the first woman and first person of color on the moon. An SLS Block 1 will launch Orion and 4 astronauts into an Earth orbit, before performing a translunar injection burn. After several days, Orion will then execute a powered flyby of the moon, along with an insertion burn to put itself into a near rectilinear halo orbit around the moon. Once in orbit, Orion will rendezvous with Starship HLS, and 2 of the crew will transfer over, Starship HLS will then separate and descend to the surface, touching down near the lunar South Pole. The crew will remain on the surface for 6.5 days, where they will explore and conduct experiments, while wearing next-gen EVA suits built by Axiom Space. After this time, Starship HLS will then propel them back into orbit, where they will rendezvous with Orion. After the crew is transferred back over, Orion will then perform an orbit departure burn, shooting itself towards Earth for re-entry and splashdown. The fourth Artemis mission is planned to launch in 2027 and will include the first crewed entrance of Gateway. This time, the more powerful SLS Block 1B, launching from Mobile Launcher 2 at Kennedy Space Center, will send Orion and 4 astronauts, along with the IHAB module, into an Earth orbit, before performing a trans-lunar injection burn. Once in lunar orbit, Orion will rendezvous with Gateway, where it will attach the IHAB module, allowing the crew to board the station. 2 of the crew will then board the docked Starship HLS and descend to the lunar surface for a multi-day mission. The Starship HLS will then return them to Gateway, where they will reunite with the other 2 crew, board Orion, and propel back towards Earth for re-entry and splashdown. The fifth Artemis mission is planned to launch in 2028. It will follow the same launch procedure as Artemis 4, but instead will deliver the Esprit module to Gateway. And once at Gateway, instead of using a Starship HLS, the crew will descend to the surface with a LETS lander. This lander will bring along NASA's Lunar Terrain Vehicle, an unpressurized rover that will drive astronauts around the surface. After another multi-day mission, the LETS lander will then return the astronauts to Gateway, where they will board Orion and propel back towards Earth for re-entry and splashdown. While Artemis 1 through 5 are the only planned missions so far, following missions have been proposed. Artemis 6, which would launch in 2029, would deliver the airlock module to Gateway, while performing another crewed landing. Artemis 7, which would launch in 2030, would perform another lunar landing and would deliver the Habitable Mobility Platform, a large pressurized rover used for long-distance journeys of up to 45 days. Artemis 8 in 2031 would deliver the Lunar Surface Habitat, a permanent base camp that would support astronauts for longer duration stays. Artemis 9 in 2032 would deliver surface logistics, and Artemis 10 in 2033 would deliver more logistics, while performing a longer 180-day lunar visit. Finally, in 2034, Artemis 11 would deliver logistics in the first year-long lunar crew. At this point onwards, a permanent lunar presence would be established, with crews shifting every year. Over time, the Artemis base camp could be expanded into a full-fledged lunar village, using bricks and concrete made from lunar regolith. And eventually, everyday people could start to move in, setting up mining operations and kickstarting a lunar economy. By establishing a permanent human presence on the moon, Artemis will act as a stepping stone for crewed expeditions further into the solar system, most notably to Mars. The life support systems, human habitats, and technology needed to live on the harsh terrain of Mars will be tested and perfected on the moon. In addition, Artemis will provide the infrastructure for the deep space transport, a proposed spacecraft that would depart from Gateway towards Mars, where it would then orbit the Red Planet and support crewed landings. Then, once we establish a base on Mars, we can use it as a bridge to destinations even deeper into the solar system, helping transform humanity into a spacefaring civilization. If you enjoyed this video, it would be amazing if you like and subscribe to Futurology for more videos very similar to this one. Thanks for watching, and see you next time.